Good morning, students. Welcome to class 12 online video explanation of the last chapter, that is biomolecules. In this topic, we will study the biomolecules, under which the definition of biomolecule and different examples of biomolecule. I put the star mark what is there in our revised syllabus, that is carbohydrate, protein and nucleic acid. Vitamins, enzymes and hormones are deleted from the revised syllabus. Now, what are these biomolecules? These are the organic molecules or carbon compounds, definitely, which constitute or which makes the living system, and these are necessary, essential for the growth and sustenance of the living system. These are also helpful to carry out the biochemical processes. Most of the biochemical processes like digestion or breaking down of the nutrients into fine or ultimate monomers that could be absorbed by our body, that is done by, these are called the biochemical processes. These are carried out in presence of certain enzymes. Mostly these are enzyme catalytic reactions. So all these biomolecules are helping to constitute the living system, to maintain the whole system of organism, as well as helps to carry out the biochemical processes. We have certain examples of biomolecules: the carbohydrates, proteins, fats or lipids, vitamins, hormones, enzymes and nucleic acids. As I said, we have to study only carbohydrate, protein and nucleic acid in this revised syllabus. Let's see what is carbohydrate. These are the polyhydroxycarbonyl compounds. Now, what do we mean by polyhydroxycarbonyl compounds? These are having more than one OH group or hydroxyl group and one carbonyl group. As you know, the carbonyl group could be aldehyde or could be ketone. So it is having more than one OH group as well as one aldehyde group or one ketone group. It has a general formula. The simplest carbohydrate could be represented as CXH2OY, where X and Y may be same, may be different. If X is equal to Y, this is monosaccharide, as C6H12O6 could be written as C6H2O whole 6. The number of carbon and number of H2O units are same. It is monosaccharide, and in case X is greater than Y, the number of carbon is more. It is either oligosaccharide or polysaccharide. For example, C12H22O11, sucrose, maltose, lactose, all these are disaccharides, a part of oligosaccharide, could be represented as C12H2O whole 11. Then this carbon number is greater than that of water 1 unit. Let's see various types of carbohydrates. One is sugar and non-sugar. Basically, we classify the sugar and non-sugar into 2 points. Sugar is sweet, while non-sugars are tasteless. Sugars are soluble in water usually, while non-sugars are insoluble in water. Sugars have relatively simple structure, while non-sugars have branched chain or highly complicated structures. The sugars can further be classified to reducing sugar and non-reducing sugar. The reducing sugar is one which can reduce mild oxidizing agent or which can itself be oxidized by the action of mild oxidizing agents, while non-reducing sugars do not respond to the test with mild oxidizing agents. As you know, the mild oxidizing agents are Tollens reagent, filling solution and bromine water. If you could recall, we had already performed the silver mirror test, that is Tollens reagent test, filling solution test, and bromine water though we did not perform. In fact, what happens when the reducing sugars are treated with Tollens reagent, it gives a uniform lining of silver in the wall of the test tube. It means that it can reduce the mild oxidizing agent to silver while itself can be oxidized. Also, the reducing sugars decolorizes bromine water, and with filling solution test, the blue color of the filling solution is changed to red precipitate. That is because of the formation of Cu2O copper 1 oxide that you will get in this Tollens reagent test or filling solution test detailed in the oxidation of aldehydes, that is already discussed in aldehyde ketone carboxylic acid chapter. While non-reducing sugars containing mostly ketonic group, or even if aldehyde groups are there, these are not free aldehyde groups, so they do not react with mild oxidizing agent and then they do not respond to silver mirror test or filling solution test or bromine water test. Now, on the basis of hydrolysis, carbohydrates are classified into three groups: monosaccharide, oligosaccharide and polysaccharide. Monosaccharides cannot be hydrolyzed into any simpler units further. For example, C6H12O6 cannot be further hydrolyzed, while oligosaccharides on hydrolysis gives 2 to 9 units of monosaccharide. And if 2 units of monosaccharides are produced after hydrolysis of oligosaccharide, this is called disaccharide. So you could guess, if 3 units are there, it would be trisaccharide. If 4 units would be formed, it is tetrasaccharide, 5 pentasaccharide, 6 hexasaccharide, 7 heptasaccharide, 8 octasaccharide and 9 nonasaccharide. So it gives 2 to 9 units of monosaccharide. While in polysaccharides, we will see that on hydrolysis it gives 10 or more than 10 units of monosaccharide, as in the case of starch or cellulose. These are the polymers of glucose only. One is alpha D plus glucose, the starch, and that starch also contains further amylose and amylopectin. However, the starch and oligosaccharides are out of your syllabus, beyond the scope of your revised syllabus. This was there in your previous year, but now this is being deleted. Classification of monosaccharides. As we know that monosaccharides has to be polyhydroxycarbonyl group. That means minimum 2 OH groups would be there, and if minimum 2 hydroxy groups would be there with at least 2 hydroxy group into different carbon, as we know that 2 hydroxy groups cannot be possible to have in the same carbon atom. In case one carbon has more than one OH group, it readily undergoes dehydration, removal of water, and changes to carbonyl group. So, if monosaccharides has to be a polyhydroxy carbon compounds, at least 2 OH group would be there in 2 different carbon, and 1 carbon is for aldehyde or ketone group. So minimum 3 carbon would be needed. Based on this number of carbon, it could be named as triose, tetrose, pentose, hexose and heptose depending upon the number of carbon. If 3 carbons are there, it is triose. 4 carbons are there. It is tetrose, 5 pentose, 6 hexose and 7 heptose. Here the simplest triose I have shown. If it is aldehyde group, it is known as glyceraldehyde, and if it is ketone, it is known as dihydroxyacetone. It's obvious that I wrote only the common names which are more important in this biomolecule chapter, not the IUPAC names. IUPAC names are quite easy, you can write by yourself only, but the common names you have to learn a bit. Monosaccharides are also classified on the basis of which carbonyl group is present into them. Whether it is aldose, means aldehyde group is present, or it is ketose, where ketone group is present. So glyceraldehyde, which I have shown you, it is an example of aldose, while dihydroxyacetone is the example of ketose. Now, in case the overall classification of monosaccharide is done on the basis of number of carbon as well as the carbonyl group. For example, glucose has 6 carbon and 1 aldehyde group. It is aldohexose. Aldo for aldehyde group, and for 6 carbon it is hexose. It is not aldose hexose. Only one OSE will be there. So it is aldohexose. Similarly, for fructose, ketone group is there and 6 carbon are there. So it is ketohexose. If glyceraldehyde would be there, 3 carbon are there and 1 aldehyde group, it is aldotriose. And for dihydroxyacetone, it is ketotriose. In case if 4 carbon would be there with aldehyde, it will be aldotetrose. 5 carbon with keto, it will be ketopentose, and so on. So that's all about the classification. In the next day, most probably in the live class, we will be completing the structure of glucose. Thank you.